This is the video for the second review quiz, Quiz B, for the Chapter 2 Prop Stats test. Feel free to just watch the ones that you have wrong. You should have tried this already before watching the video. If you haven't tried the problems yet, then stop now. Come back to the video after you've submitted. Question 1. A jar contains 4 white chips, 5 purple chips, and 1 black chip. That's a total of 10 chips. Chips are randomly selected one at a time and are not replaced. That's a really big deal. Find the probability of the following. We want our answer to be as a percent rounded to the nearest tenth of a percent. Let's get this going. So the probability of purple and then black, that's the probability of purple first and black second. So what that means is out of 10 chips, we want the probability that we pull a purple chip. That would be 5 out of 10. Next, times, there's only going to be 9 chips for this second pull. And the reason is right up here. Our chips are not being replaced. That makes this a dependent probability problem. So there's only 9 left, and only one of them is black. So we could simplify the 5/10 to 1/2. So we have 1/2 times 1/9, or 1/18. That would be a simplified fraction, but we want nearest tenth of a percent, so that would be 5.6%. Black, then white. So black first, white second. There's only 1 black out of 10. For the second one, there's only 9 chips left, and 4 of them are going to be white chips. I can simplify just a little bit. The 10 and the 4 are both even, so I can reduce those by dividing both of them by 2. And then we have 1 times 2 up top and 5 times 9 on the bottom, 2 out of 45. So as a percentage to the nearest tenth, that would be 4.4%. Purple and then white. So the probability that we get purple first, we want purple first and then white second. So out of 10, the amount that are purple is still 5. And then again, we have to make the second fraction out of 9. There's 4 white total, so that would be my probability of having purple first and white second. The first fraction is 1/2, and then I can, after that, simplify the 2/4 into a 1 and a 2. So up top we have 2, on the bottom we have 9, so this will be 22.2%. And then this one wants 3 in a row. So purple, probability of white times probability of purple times probability of black. Okay. When we look at doing this one, the probability that it's white first is 4 out of 10. Then there's only 9 chips left, but there's 5 purples left. Then there's only 8 chips, and there's only 1 black total. So this one is 3 fractions long. I can simplify things a little bit from here. 4 out of 10 is just 2 out of 5. But then we have a 5 up top and a 5 on the bottom that can cancel. So that's 1 and 1. And then this 2 that I just had here and this 8 can simplify. So this will be 1, and we have 4. So on the top, we have just 1. 1 times 1 times 1. On the bottom, we have 9 times 4. So there's a 1 in 36 chance of this. I actually don't have this one punched in yet. We want the nearest tenth of a percent, I should say. 1 out of 36 comes to 2.8%. And that's how we're going to do number 1. Number 2 just asks us what we were just doing. So this one actually arguably should have been first. Same exact question. They want us to just understand the vocab. It's an example of which kind of probability. So this was an and problem. So this was a multiply problem. So it can't be mutually exclusive or non-mutually exclusive because those are for or problems, for adding problems. Since our chips were not being replaced, that made our fractions change. The denominator had to change each time, which means that this is an example of a dependent probability. Number 3, there are 3 literature books, 4 algebra books, and 2 biology books on a shelf. That's a total of 9. If a book is randomly selected, what is the probability of selecting a literature book or an algebra book? So I see the word or means add. So when I have adding problems, I have to worry about whether they are mutually or non-mutually exclusive. So it can't be independent or dependent. That is for an and problem. I have to ask myself, can I pick something that is both at the same time? If something is a literature book or an algebra book, can that happen at the same time? Can I pick one book that is both an English and a math book? The answer is no. So since these can't happen at the same time, they're not non-mutually exclusive. We call this mutually exclusive. In other words, we wouldn't have to subtract the overlap. There would be no overlap. So let's find out the probability of that then. Number 4. Now that I told you there's no overlap, the probability of a lit book plus the probability of an algebra book is all we need to worry about doing, because that we can't have both, which means we don't have to subtract. So there's 9 total, remember, 3 plus 4 plus 2. So the literature book would be a 3 out of 9 chance. The algebra book would be a 4 out of 9 chance for a total of 7 over 9. Maybe we should read the directions now, find the probability, and record as a percent to the nearest tenth again. So this would be 77.8% if I'm rounding to that nearest tenth. All right, last 2, numbers 5 and 6. Each of the numbers 1 through 10, that's a total of 10 numbers, is written on a card and placed in a bag. If one card is drawn at random, what is the probability that we get either a multiple of 2 or a multiple of 3? So let's look at the numbers that are possible to pick. All right, this is an or problem again, which means it can't be independent or dependent. We have to see, can these things happen at the same time? So I'm going to circle all the multiples of 2. 2, 4, 6, 8, and 10. Now I'm going to circle all the multiples of 3. 3, 6, and 9. If you notice right here, we circled 6 with both colors, which means 6 is a multiple of 2 and a multiple of 3, which means there is overlap, which means this would be a non-mutually exclusive event, since there is overlap. Okay? So let's answer the question. Each of the numbers from 1 to 10 is written on a card and placed in a bag. We want to know the probability that we get a multiple of 2 or a multiple of 3. So that would be the probability of multiple of 2 plus the probability of a multiple of 3. Since we said it's non-mutually exclusive, we have to subtract the probability that we get a number that's both. So there's 10 numbers for each of these. Let's scroll back up. Here's what I had for the number of multiples of 2 was 2, 4, 6, 8, and 10. That's 5 total multiples of 2. Multiples of 3 was 3, 6, and 9. So there's 3 of those. And then there's one number that was both. 6 was in both the multiple of 2 group and the multiple of 3 group. So that would be a total of 8 minus 1, so a total of 7 over 10, 70%. Feel free to rewatch or ask your teacher if something there doesn't make sense. All good review for the test coming up. Thanks for watching.